Most AI models give answers, but don't show how they think.
Welcome to The Explainer. Today, we are diving into something really cool. How do you teach an AI to actually show its work? We're not just looking for the right answer, we're looking for the reasoning behind it.
You've probably experienced this. You ask an AI a question and poof, an answer appears, but you have absolutely no idea how it got there. It feels like this mysterious black box, right? And that makes it super hard to trust, especially when it really matters. But what if we could take that kind of wishy-washy guess on the left and turn it into the logical step-by-step breakdown you see on the right? That's the whole game, turning that mystery into total transparency. And that right there is the core challenge that researchers are trying to crack. It's called the black box problem. The whole goal is to move away from these opaque, kind of sketchy answers to reasoning that's actually clear and transparent. So the solution they're working on is to teach an AI, in this case a model named Gemma, to create what's called a reasoning trace. Basically, it's forcing the AI to think out loud, to show every single step of its logic from start to finish. And here's what that looks like in practice. It's brilliant. The AI isn't just asked to explain itself, it's trained to wrap its thoughts in these neat little tags. You have the thinking part and then the final answer. This structure makes sure the explanation is always consistent and super easy for us to read. Okay, so how in the world do you teach a machine to do that? Well, researchers came up with this really clever two-stage training plan that builds this skill piece by piece. The whole process is broken down into two main parts. Stage 1 is all about the basics. It uses a technique called Supervised Fine-Tuning to teach the model the correct format and the basic rules of the road. But then Stage 2 kicks it up a notch. It uses reinforcement learning, learning from rewards and penalties, to really sharpen the quality and the correctness of the AI's logic. A really simple way to think about it is like sending the AI to school. Stage 1 is like grammar school. It's just learning how to structure its sentences and follow the formatting rules. Stage 2, that's advanced training, where it learns how to build a logical, coherent, and, most importantly, correct argument. Okay, so here's the secret sauce. How do you go from just following the rules to producing really high-quality logic? It all comes down to a super clever grading system. Basically a reward function that scores every single answer the AI comes up with. This grading system looks at 4 key things. First, is the structure right? Did it follow the format? Second, is the final answer actually correct? It also gives the AI a little bonus for being confident, but only when it's right. And critically, there's a small penalty if it starts rambling, which keeps the explanations nice and concise. But this is where it gets really, really interesting. They use a technique called reward annealing. What that means is the grading priorities actually change over time. It starts by focusing on how the AI says something, and then it gradually shifts to caring more about what it's saying, from form to substance. So in the beginning, during the early training, see that big slice of the pie? That's trace structure. The model gets most of its points just for getting the format right, following those grammar rules. Being correct is important, sure, but nailing the structure comes first. But then, later on in the training, watch what happens. Boom! The whole thing flips. Correctness is now worth a massive 60% of the grade. Once the AI has mastered the format, the system really pushes it to prioritize getting the right answer above everything else. So after all of that, the complex training, the clever grading, the shifting priorities, does it actually work? Well, let me tell you, the results of this transformation are incredibly clear and, honestly, pretty stunning. Just look at this example. Before the training, the model gives this hesitant, one-line guess. 6 days maybe? But after, for the exact same question, it produces a perfect, step-by-step logical breakdown. It literally shows its work, from the first calculation to the final conclusion. And this wasn't just a lucky shot. Across a whole bunch of different problems, the average reward score, that's our quality grade, jumped by 0.826. In the world of AI training, that is a massive, massive leap in performance. Now look, this is way more than just a neat technical trick. Making AI transparent like this has huge implications for how we're going to use, and more importantly, how we're going to trust these powerful tools in the future. So what did we learn from all this? Well, a few really powerful things. We know that teaching the format first is a super fast and efficient way to get started. We learned that a smart curriculum, going from easy problems to harder ones, is absolutely crucial. And we know that these carefully designed rewards, like the annealing and the penalties, are what really create reliable and trustworthy answers. And that really leaves us with this big question, doesn't it? Once an AI can consistently and clearly explain how it thinks, a whole new world of possibilities opens up. It's the first real step toward building systems we can truly work with and trust. The question isn't if we can trust AI anymore, it's where do we want to trust it first?